Today, we're hopping in our time machine and we're going to visit the day the dinosaurs died. And you can too at the KPG boundary, which you can see at Big Bend National Park. Why don't you tell them all about it, Kai?
Behind me is the KPG boundary. It is a layer of rock that stretches across the whole world that has an element not from Earth, iridium. And that element is what tells us that this was an asteroid that hit the Earth 65 million years ago. It was this event that wiped out the dinos. It wasn't the Ice Age. It wasn't overhunting. There were no cavemen. And it wasn't the rise of mammals. It was an asteroid. This is the worst day on the Earth. Right there.
But finding this geologic marker and agreeing on what it meant is an epic tale of a father-son duo, skeptical scientists, missed opportunities, and one very large crater hiding in plain sight. We'll tell you all about it today on 9 Worlds.
The KPG boundary is the layer of rock and earth that distinguishes the transition between the age of dinos and the rise of the mammals.
This layer of rock has been identified in more than 100 places worldwide, and it's remarkably thin in some places, typically not more than a few centimeters wide. This is the dividing line between the Cretaceous era, which is the period from 145 to 66 million years ago, and the Paleogene, which occurred 66 to 23 million years ago. You may have heard of this by the more historical but now less accurate term KT boundary. Both denote the same layer of rock.
Below the line of rock, there are a bunch of dinosaurs and Cretaceous era creatures, and above it, there are no dinosaurs to be found. This abrupt change in the fossil record was an early clue to scientists that something big was going on in the past. A massive extinction that killed almost 75% of life on Earth. But what caused it?
Well, in the 1970s, Walter Alvarez, a geologist at UC Berkeley, was conducting research on this boundary layer in Gubbio, Italy. In his lab, Alvarez found that the clay from his Italian rock sample had incredibly high levels of iridium, levels tens to hundreds of times greater than the rocks typically found in Earth. This was strange because iridium is not only rare, but most of it on Earth is found near the core of our planet and not in the crust. This was a mystery. To help him figure this mystery out, Walter called upon his father, who happened to be a Nobel Prize-winning physicist. Now, together, they hypothesized something amazing. The iridium Walter found in the KPG boundary wasn't from Earth at all, but rather originated in space. While rare on Earth, meteorites have lots of iridium. So if an asteroid hit the Earth and the debris from that collision was distributed into a cloud surrounding the planet, only to eventually rain back down to Earth, then you would find a small sedimentary layer exactly like the one found by Walter with high levels of iridium in places all around the world.
Putting all the puzzle pieces together, they formed a hypothesis called the Alvarez Hypothesis, which stated that there was a meteorite that hit Earth, and the proof was this iridium layer that was everywhere around the Earth.
So the mystery of the dinosaur extinction was solved.
No.
No?
No.
No.
It's okay, everyone makes mistakes. And it wasn't exactly solved. I mean, a crater that could do that much damage had to be massive. But there was no crater that size recorded on Earth. Most scientists didn't even believe it was an asteroid that did it.
But as it turns out, that giant crater was hiding in plain sight all along. It's just that no one in the scientific community was paying attention. About the same time that Walter was examining clay from Italy in the late 1970s, 2 geophysicists working for the Mexican oil company Pemex, Glenn Penfield and Antonio Camargo, found some magnetic and gravitational anomalies in data they collected from the Gulf of Mexico, just north of the Yucatan Peninsula. When they mapped these anomalies, they created a clear, shallow bullseye about 180 kilometers in diameter in the Gulf, just like a crater from a giant asteroid would.
Penfield and Camargo believed that they had hit an impact crater, possibly the one that killed the dinosaurs, the one with iridium, the KPG boundary, that crater.
As any good scientist would, they excitedly attempted to share these findings with the scientific community in 1981 with a presentation to the Society of Exploration Geophysicists, where they basically said, hey everyone, think we may have found the crater of the asteroid that killed all those dinosaurs? Except that most of the researchers who were studying the KPG boundary were at a different conference where all those researchers were busy telling the Alvarezes why their theory was wrong because no one knew of any crater on Earth that would substantiate their impact theory. So no one noticed that the crater had been, in fact, found.
But Penfield didn't give up. He knew that the drilling company had to have some samples of the crater area, but he couldn't find them, which means he couldn't study on them. He even sent a letter to Alvarez, but Alvarez never sent it back because he was looking for the crater. Hey.
Fast forward 10 years to 1990, and Alan R. Hildebrand, another scientist studying deposits from the KPG boundary, gets introduced to Penfield, and together they find those drill samples from the Pemex wells, which had just been sitting in New Orleans for decades, apparently. And when Hildebrand's lab tested those samples, surprise! They very clearly showed evidence of impact metamorphism, the kind of changes that occur under extreme pressure and the heat conditions of an impact event. This was the physical evidence supporting the site as an impact crater.
Hildebrand, Penfield, and Camargo, and many others, finally published their paper in 1991. They named the crater after the nearby town of Chicxulub.
But it would take until 2010 for a panel of 41 international scientists reviewing 20 years worth of data about the KPG extinction to conclude that, based on the evidence, the Chicxulub space impact was the only plausible explanation for the devastation that occurred 66 million years ago that we can see noted in the geologic boundary. The data that points to this as an explanation includes the abrupt change in the fossil record, the iridium identified by the Alvarezes, the impact crater, and other findings including impact ejecta and shocked quartz found in patterns and locations consistent with this theory. We hope you're enjoying this video, and maybe you're sitting there wondering, where can I see this magical line in the Earth's crust that denotes this terrible day in mass extinction? Well, as it turns out, there are some sites in Colorado and New Mexico where the boundary is visible.
But if you're into U.S. national parks, you should head to Big Bend National Park.
Here, there are 3 different places where the Earth reveals this boundary within the Javelina Formation on the west side of the park and the Black Peaks Formation on the northeast side of the park. Check out their fossil discovery exhibit for more information, and we'll tell you all about it here in this video.
Thanks for watching. Please subscribe so you can see more awesome science with us. And if you want to be really kind to us, subscribe so hard that it's like Chicxulub, like